Hello there, and welcome to another exciting episode here on the Green Living Chat podcast. Today, Daniel and I bring you an exciting conversation on the Research Stories segment.
Hi everyone, in this episode, we dig into discussions on artificial intelligence and sustainability, where we explore how this works in both industry and research. We hope that you find a place where this can enrich in your research story. Professor Peter Shaw is an Australian scientist with extensive applications in artificial intelligence, which he has been doing for more than a decade now in the areas of FPT algorithms, medical research in cancer treatments, as well as enhanced machine learning network models, among others. He is currently working at the Nanjing University of Information Science and Technology. Professor Peter Shaw has several high-level publications as well as distinguished academic and industry awards, which include an Emmy Technology and Engineering Award and the Jiangsu 100 Foreign Talent Research Grant. He is also a pleasant person with whom to drink coffee. Have you ever wondered how artificial intelligence helps us to develop solutions in our everyday lives? In this exciting episode, Professor Peter Shaw joins us to discuss some of the ways AI is being used, ranging from cancer treatments in the medical sciences to sustainability and more.
Yeah, so on today's segment, we got a little nerdy and we talked about how Peter got into computer science and how he's using it to find solutions in the medical field. We also talked about the significance of AI and research in the medical field and how AI can be applied in sustainability.
What does artificial intelligence mean for sustainability, and what are the ethical issues we are being faced with as we become more dependent on AI? These and more in our discussion.
It was a super interesting conversation, and I really can't wait to share this conversation Daniel had with Peter Shaw on this particular episode. So why don't you grab a coffee and let's dive into this conversation. Here we go. You are listening to the Green Living Chat podcast, a podcast where we discuss emerging environmental issues around the world, as well as related ongoing research to find sustainable solutions. This is the Research Story segment. I am your host, David Ewisi-Mensah, with your co-host,
Daniel Fifi Teria Hagen. We use this platform to support environmental-related initiatives, research, and projects through interdisciplinary conversations that promote holistic critical thinking.
This podcast is brought to you by EcoAmet Solutions in Ghana, with a mission to going back to green. So join us on this train this and every Sunday. Here we go.
All right, guys, I'm here today with Professor Peter Shaw,
Hi.
who is, Peter is a good friend of mine. We are currently both at the Nanjing University of Information Science and Technology. And Peter is doing something that I know a lot of you are very curious about and are probably scared to go into. He's an AI expert, and he's going to pour out his expertise to us in very simple ways with simple words. And we hope that this conversation will just serve as some sort of motivation for some of you who are probably thinking of going into AI, but not sure what you can do with AI. We can't cover everything, but Peter is going to make sure he gives you at least something to whet your appetite and to get you interested in AI. And more specifically, today we are looking at AI and sustainability. We're going to go straight into our conversation. Welcome, Peter. This is Green Living Chats podcast.
Thank you. My area is actually computer science, in particular, a type of optimization, general optimization called parameterized complexity, which is a new approach to solving otherwise hard problems. So then how does this apply to AI, and how did I get into it? So a lot of theoretical computer science ends up being very good for digesting coffee, but totally useless, where AI has generally been quite useful recently. This is an oversimplification, of course, so I don't want to offend my friends. We really try and be helpful. But when I tried to apply my computer science into the real world, particularly medicine, what I found was that there was a sort of probabilistic interface that we had to solve. By probabilistic, I include statistics and machine learning in that sort of bucket. The thing that I think computer science can help with in this whole area as a type of mathematics is we think about how expensive it is to solve a problem, where mathematicians think about how to solve the problem. They think, is it computable or is it not computable? But they don't think, how much resources do you need to compute it? And so this causes a big disconnect. And in fact, I think it's a fairly huge disconnect when it's coupled with electrical engineering.
Okay. Before we get into serious conversations, could you tell us about yourself, a brief discussion of who you are, what we need to know about you? Let us know how your journey has brought you to this point.
Sure. So I'm an Australian. I'm not a meteorologist like Daniel. I'm a computer scientist who's trying to apply his research into AI. But I still think there are some significant sort of conclusions that we can get from that about applying AI into the whole situation. Of course, the most topical thing that I saw presented recently, there's a famous computer scientist well worth listening to, Mosavadi, who is one of the leading fellows in the ACM society. And he recently posted a nice picture, we could even put it as a backdrop maybe later, showing the crossover between diminishing returns of AI and the benefit on the environment from AI research.
Okay.
And so with any science, with any advances, the benefits sort of eventually get some sort of diminishing returns. And at the same time, I think everybody who uses a computer will be aware of the power consumption increase of these devices. And I think when I started using computers, they're actually really big things, which had paper tape and power supplies that made the room hum. But when a lot of people started using computers, they had like 30-watt power supplies in them. And when I was using my computer today, I made sure to open the window so it wouldn't overheat, because it's got a 1600-watt power supply in it. And I was actually thinking in a recent proposal I put out for my computer to offset the electricity that I was using with wind generators as a way of sort of arguing that I wasn't using too much power. So put that on a slightly different perspective. It was sort of a joke we're having around about 2003. So going back to the question that Daniel asked me, I did my PhD at the University of Newcastle under Professor Michael Fellows, who has now become really quite notorious. He's in my area of computer science, he's famous for developing parameterized complexity, which is a way of solving problems that are otherwise thought intractable. What does intractable mean? It means no matter how big your computer is, even if it was as big as the universe, that is one processor for every atom in the universe running at the speed of X-rays, you wouldn't be able to solve these problems. Wow. But he developed a technique that allows us to solve some of these problems within, by constraining it into a realistic paradigm and a way of working out what is solvable or not. But given the topic, if we sort of Scooby-Doo back to that point, a lot of problems that are computable, that is, in theory, you could get a computer to solve them. In practice, computable means that without constraining your mathematician, they may want to run it on a computer the size of the universe. at X-ray speeds. Well, that's an awful lot of power if you consume all the energy in the universe to solve your problem.
Yeah.
And would have, I guess, fairly severe environmental damage, not only to our planet, but everything else in the universe. So without placing some realistically constraints on what we let our AI model do, it could just be totally out of control and use every bit of power that was available to our sun. No, we're not there yet, but I mean, in terms of the theory of the mathematics, that's going to be a pushing force towards trying to solve any of these problems, that you could literally use the entire electricity of some country. So that brings me to my story that after doing my PhD, I was listening to a discussion group, and the person coming to visit was from the electricity grid in the US. And he was very happy. He said they'd recently changed their supercomputer and they would like to invite us to use their new supercomputer. And then he secretly said the reason why they'd changed the computers wasn't because they needed the extra compute. It was that for some time now, it had been appearing on their power usage as the single line of most power consumption in America.
All right.
So they bought a bigger one so that it was a little bit more efficient for a moment, and came up at like the third biggest use rather than the first.
So you got interested in this, and how did you sort of find areas of application of your expertise?
Well, of course, I really liked the mathematics and the graph theory and the drinking coffee, but I had a lot of my friends die of cancer. And so I had this desire to want to fight back while I could solve these combinatorial problems and optimization problems. When you go to speak to somebody like a doctor or like Daniel and say, how can I help you? They don't initially present their problem as a graph theory problem.
Mm-hmm.
And so it has this translation step between understanding what they want you to solve and what you solve for them. Of course, there's a few parts of that. One is listening to the person. Listening is always a big part. And the second, though, is this probabilistic mapping between the observations that the person has and the combinatorial problem. So the good news, I think, in solving the combinatorial problem is if you look at the power used, it's sort of roughly proportional to the running speed of your algorithm. And so if you look at the speed up of the algorithms that we have between now and 20 years ago, I looked it up about 3 years ago when I was teaching. And so the speed up was something like, I think about 200 times in terms of the computing power, but it was about 11,000 times in terms of the program's running speed because of improved algorithms.
I can see
so there's actually been a huge increase in the speed at which we can solve these problems from the computer science, much greater than the speed increase from the electronics. In fact, right now, the electronics is smashing up in terms of a lot of fundamental physics laws. And one of those is that the increase in speed that you get of your processor is quadratically related to the power that you use. So if you want your machine to run twice as fast, then you need to have 4 times the power. For 4 times as fast, you need 16 times the power. So, of course, parallelism breaks that down a little bit, but not entirely. So this great propensity for just a little bit more speed to require significantly greater power. And I think then the second thing in terms of environmental damage for computers is the short-term vision that the whole computer industry has brought on the environmental impact of what we're doing. So when computers were first built, when I started using, they would have 1 computer per institution. They weren't too worried about the environmental impact of those. And I think in much the same way as a hospital is not too worried about the radiation effect of having an X-ray machine, because they mix the pollution, the radiation from the the X-ray machine with all the other pollutants sheets and bedding and cotton wool that comes out of the hospital. And so on average, it's pretty small. And so when they were thinking about this with computers and a lot of electrical devices, they were just worrying about trying to get something that works to win the war on the Second World War, and then win the war on some very pressing issue. And over the time, the cost of this pollution is mounting up. And because of this Moore's law, the fact that every 2 years, the running speed of your computer doubles, and we're wanting to keep increasing the performance of our machines so that they can keep up with the speed of the programs we expect it to run. I think there's a lot of economic pressure. As we know, Apple likes to deliberately make our phones run slower and force us to buy new ones as well. Fundamentally, people are always needing to get faster machines. And so we're throwing these things away and buying new ones.
Yeah, I think you're already going into sort of sustainability over there. I really want us to continue that conversation because it's certainly something that our listeners are interested in, and it is the focus of this podcast. We will definitely build up on that over there. So before we come back to that, I wanted you to sort of finish up on the cancer story that you started over there. What are some of the things that you've been able to do with AI in the study of cancer?
Yeah, so the initial things that I was wanting to do was solve some real problems that were useful for doctors. So I went and I spoke to them about what problems they would want me to solve. And this actually meant talking to the people at the University of Knoxville, Tennessee. And they wanted to be able to analyze bigger data sets. And for that, what they needed was some pre-processing rules that could be run on the data sets. In particular, there was a problem that I've looked a lot at called cluster editing, which is a sort of noise reduction algorithm. And they'd only been able to run it on fairly small data sets, like under 10. And I managed to find a generalized reduction rule that increased the size that we could handle up initially to thousands, but now with my recent work, maybe 100,000 variables that we're looking at. So this was a big win. But as I said, this was for solving what was essentially a graph theory problem. And so I then had this interest in applying it to medicine. So initially, I first used statistics to turn the results into some medical results. And then, as we all know, there's been this tremendous growth in deep learning. And so I looked at how I could use deep learning as well to apply this into the medical area. And in the medical area, the first problem I was looking at was lung cancer. And what really people would like to be able to look at is, can we identify which genes or which RNA are part of some system? So if you imagine looking at a picture of a traffic light and there's things going whoa, whoa together, then these would all be correlated variables. Yeah. And so we'd like to be able to find those variables and link them together. And maybe you have two groups of variables together. If you think of a room of people, maybe some people are there because they want a cup of coffee. Maybe some people are there because they're part of that class. Maybe some people are doing medicine and they want to propose some medical problems to the group. And so there are some people that will be part of two or more of those groups. And so identifying those groups and identifying people that are part of more groups then becomes a very useful thing to do, in addition to predicting some important variable like when will the class finish and when can I get out of the room, which might be the decision problem we want to solve. It's useful to also understand the system that you're going through. In a medical perspective, this is medical pathways, although in different domains, they have different ways of describing it. I think Daniel likes to look at this in terms of entropy and causality. Yeah, so this is the network models that I was producing. I was getting the variables. I was doing pairwise correlation between them. So what was the similarity between all pairs of variables? And then I was trying to use network models to group them together, but allowing some level of false positives and false negatives, error in the data. and identifying possible error. So this tool I got working very well. And then I was able to apply it to more and more problems. I've been looking at applying it to a lot of the Indigenous health issues in the Northern Territory. The Aboriginals in Australia are really quite repressed. And also because they've been only recently introduced to the Western diseases, their genetic immunity to these diseases is very limited. In the same way, we're very susceptible to getting COVID. And so we've had to work very hard to try and help them.
Wow. Just a final follow-up question on that is, have you seen some of your research sort of materialize in the real world, or have you received any feedback from any of these medical experts that you sometimes work with or that you sometimes speak with?
Sure, yeah. So I'm working with the Menzies School of Health Research. And so one of the things that I've been doing also recently is being involved in a lot of systematic review and meta-analysis, which is an attempt to more scientifically codify how the results of a lot of different papers can be put together and come up with a result. And so recently I've been sort of aggressively criticizing some of these studies. And the way this has come about is the doctors I've been researching with have approached me and my friends Rama and said, this particular paper that we read, it's dangerously wrong. Can you do something about this before it changes a policy and hurts people? And so we've gone and read this paper and realized the mathematical faults that are there, and then written a review paper that points it out to the other readers.
Can we clarify nomenclature quickly before we move on, just in case some of our listeners are not clear on machine learning, artificial intelligence, which we're calling AI, and deep learning? Could you quickly give us some clarity on these three terms?
Sure.
Yeah.
So, well, when AI came about, there's a sort of cheeky comment made by when someone said, well, what is AI? And the comment was, AI is what is new. And as soon as you can get a computer to do it, then it's no longer intelligence. And so then we have to do something more impressive. So this is a sort of definition of AI. I sort of use this to try and argue a point where I'm trying to do some sort of person-on-a-chip simulations to validate the models that I get with one of my friends, NASA, who is a sort of expert on microfluidic experiments. And my argument was that that's sort of AI because it's new. So I was trying to push the envelope a little bit in the definition of what AI is. But AI definitely also includes sort of some bigger concepts about training of and obtaining data sets. So in a statistical approach, you would always come with your data pre-recorded and then get some conclusion from it. And in AI, you've got ideas like reinforcement learning, where the data is continuously being connected by the Tesla cars driving around the road, being used to retrain the model to get it better. So then we have this area of machine learning, and machine learning has got this new area which is called deep learning. So I think machine learning is in my mind, probabilistic models, which of various forms, Bayesian models, random forests, and other models like that. And then you have a particular type of model now, which is called deep learning. So what's the difference between machine learning and deep learning? In my mind, deep learning is a very cool marketing name for a particular type of model. But I'll try and explain it in a slightly different perspective. One of these sort of traditional models is called a support vector machine. So a support vector machine basically says, if I have in 2 dimensions, some red dots and some blue dots representing 2 types of data, maybe sick patients and well patients, and I want to classify them, and I want to draw a line between them. Maybe it's a straight line, or maybe it's a curved line. Then calculating that line is a support vector machine. Now, a single line separating 2 points ends up being mathematically equivalent to a neural network with one row in it.
Okay.
So what's the difference between one row in a neural network and multiple rows that we call deep learning?
Just for our listeners'
And
sake, the neural network is a deep learning approach.
yeah,
Yeah.
so there's a really nice paper by Chris Ulla, who is one of the writers of TensorFlow. You might know him from his blogs talk very nicely about some of these concepts, where basically he describes in your support vector machine, you're trying to draw a straight line between these 2 points. And then if it was on some rubber, you might want to sort of stretch that rubber so that the points aligned in so that you could easily draw a straight line between them. And so every layer of your neural network is like another attempt to stretch that rubber and twist it around so that you're effectively unwrapping something like a two-arm spiral so that you can then draw a line between them. And the number of layers you need is proportional to how many times you do that.
Wow, that's a lot of fun and a lot of clarity as well.
Hi there, just a quick one. So if you're enjoying this conversation, why don't you just share this episode with a friend of a friend? And let's get more people to listen to this episode. The urgency of climate change and humans reducing our impact and footprint on the environment is a necessity. And these are conversations we need to promote. You can also help us by giving us a star rating or sharing your comments on whichever platform you are listening to this episode. Visit our website and our social media platforms in the show notes and get interactive with us, or send us an email at glcpodcast@ecoamitsolutions.com. So thank you in advance. Let's get back into this conversation.
So we will go back to the discussion that you started before. It looks as if you were going into sustainability. I hope this is not too much. I'm going to try to read a quick extract from an article that I read, written by Connor Riffle. It's called "What Artificial Intelligence Means for Sustainability." Because here at GLC, we are really looking into some of the ways that AI or machine learning or deep learning is going to help us to deal with environmental problems. So here is a very quick read. The vast majority of the mentions of artificial intelligence in reports relate to how AI presents opportunities for companies. For example, AI is helping the next generation of companies reduce their environmental and social impact by improving efficiency and developing new products. We can look at a utility company, Excel Energy. So this is the name of a company. When the company creates electricity from burning coal at its two plants in Texas, one major byproduct is a potent greenhouse gas called nitrous oxide. Nitrous oxide emissions contribute to climate change as well as harming the ozone layer. So this is very important to me, and I'm sure a lot of listeners. And it goes on to say that recently the company has received a little help in reducing its emissions from artificial intelligence. Excel has equipped its smokestacks in Texas with neural network, an advanced artificial intelligence that simulates a human brain. The neural network quickly can analyze the data that results from the complex dynamics of coal combustion. It can then make highly accurate recommendation by adjusting the plant's operation to reduce nitrous oxide emissions and operate at peak efficiency. As a result, neural networks have helped Excel Energy and over 100 other companies worldwide reduce their nitrous oxide emissions. A report from the International Energy Agency estimated that artificial intelligence control systems such as Excel Energy's neural network could reduce nitrous oxide emission by 20%. So this is a very it looks like a remarkable feat. This is something that I wish you could help break it down. How do you think artificial intelligence can help us with sustainability? I mean, you could either use this example or continue the example that you started when you were talking about computers and the upcoming algorithms that are requiring more computational power and all that.
Okay, so I'm going to take a slightly different approach to answering this question.
Sure.
Daniel probably knows that I like to do this. But then I'll try and go back to the question more exactly. So I often talk to some microbiologists or some medical researchers. My marketing pitch to them is something like this. So how much time did it take you to get that data? And they say, oh, about 20 years. And how much money did you spend collecting that data? And they say, oh, give or take about $20 million. Maybe it's a lot more. And then I say, and what did you do to analyze the data? They said, oh, we put it into this Excel spreadsheet and did a pivot diagram.
Okay.
And how long did that take? Oh, about 1 second. And so there tends to be a tremendous disconnect between cost and value of their data and the amount of human brain power that they apply to analyze this data. And in the same way, very large numbers of nicely trained mathematicians are starving, hungry, and in need of coffee and good data to analyze. And so if you reached out to find somebody's PhD student and they spent 3 months on that, they would probably produce a vastly better result than your Excel spreadsheet, even if it's got a neural network addition to it. There's some lovely diagrams you can get that basically say, look, I plugged these Lego blocks together and I got a better model, and it's very easy if you don't understand the mathematics behind what you're doing to end up with a very impressive looking number in terms of what the model claims its predictable capacity is and what it actually does. So without really doing a lot of environmental damage, I think getting a mathematician and who understands what they're doing to help you produce a better model would end up with something that used less greenhouse gas to produce and was more useful. So that's my recommendation about this. My mathematician friends are starving for coffee, and if you don't give it to them, they might hurt you anyway. The other side of this is that left unchecked, with everybody just grabbing the latest powerful deep learning model and running it on Amazon, is going to, or Google or wherever you're running it, is going to produce a vast amount of pollutants, both in terms of the coal used by the generator and also in terms of the environmental damage that's gone into getting the rare elements required to build it. And so I think that you have to remember when you're using the deep learning in particular, which is very expensive. Other things like random forests use far less power. But when you're using deep learning models, you have to think about, is the environmental damage really justified for 1 or 2% better, where actually having a sensible model will make a big difference. The training of these models can be hugely important. Like I was working on one project, this is one of my favorite stories, so I'll just chuck it in, where a container ship had lost its load. And what causes these container ships to lose their load is that some of the containers are packed very unevenly. And so they were taking pictures of containers in a packing yard, shipping yard, before they were put on the ships. And the model had said with 97% accuracy or some high accuracy that these were all packed properly. And it had failed. They'd lost a ship. And they were saying, with such an accurate model, why had it failed? And when they looked at the pictures in a sort of autopsy of this failure, they found that what the model had actually predicted was whether or not there was a rat in the picture or not. And so they'd overtrained their model.
Okay.
So when you're building these models up, it's very important to have somebody who understands what overtraining is, and this whole issue of variance and bias, and how to choose the right model for what you're doing, because a simple model is always best. And a simple model will also use less power to train. So I think that's very useful. But on the other side, the other story I wanted to give that I love to give was, this is even back in about 2007 or something. When you look at the amount of power that's used at that time by Google data center, it ends up being about the same power, half the power of a nuclear reactor. So you've got like a nuclear reactor, and half the power coming out of it is going straight into a data center. And Google's defense of that was quite rightly justified. They said, we use about half the power of our competition. So don't get upset with us. We have been trying very hard to be environmentally friendly. And probably the data center and the way they do things there is much less power than when it's distributed to everybody's home and they're running them in their own home. And, my joke at the moment is the way I'm going to keep warm during this winter is I'm just going to use the GPU on my computer a lot, because my wife doesn't like me having the heater on because it wastes electricity. But my GPU makes more heat for me than my heater anyway. So that was the plan. So I think we have to be carefully considering how much power we're using in these devices. Obviously, with the NO2 reduction and all the efficiency gains that we can get, there is a lot of benefit. And there is greater benefit still coming out of AI than the power that we're using. We can sort of plot that line, but we can see that we're getting very close to the point where the two lines cross over. So as we feed hungry mathematicians their coffee by getting more sensible models and offset our GPU power consumption by using alternative energy and carbon footprint, planting trees and things as a way to conscientiously deal with that. We may slow some of that damage down, but the amount that needs to be done and what needs to be done properly for that, I'll leave in the environmentalists to come up with their advice as well, because I'm just a coffee-starved mathematician who wants to be helpful.
Yeah, it's actually one of the things that we are hoping to encourage and promote here at this podcast, to encourage interdisciplinary conversation. And so, you'd have a mathematician, you'd have a computer scientist, and then you'd have an environmental scientist, all working on the problem, and not that the environmental scientist is blindly picking up some AI algorithm and applying it. And so, yeah, what you're saying definitely makes sense. And it reminds me of what we usually say in climate science, that, we have a climate science conference, and then all the scientists, they take flights to the place, essentially polluting the environment to manage pollution. It's one of those circle of life things. Anyway, I have a curious question: that do you think there are some ethical issues with AI, with the AI community, or with the use of AI? Are there some off the top of your head that you want to share with us?
Of course, there's ethical issues involved with it. I think one of the challenges with this whole thing is when you look at it from a higher perspective, you can definitely see they're there. But while you're doing it, it's hard to see the ethics involved. If I give you a group of numbers on a piece of paper and I ask you to add them up, then you wouldn't feel any ethical problem adding up those numbers. And so the question is, when does adding up those numbers become unethical? And of course, mathematics is this type of power, because with the knowledge that comes from mathematics, you get power. And the inevitable consequence of power and a fallen humanity is that you get bad things going on. But at the same time, it's very clear that the misuse of AI can be used in a disastrous way. Early examples for me of this, there was Target. Target was doing aggressive advertising for selling their baby products because, new mothers is a big area for business. And so there was a man with a 13-year-old daughter, and she receiving these secretly targeted material addressed to her in the mail. Her father saw this and was furious, rightly so, with Target for sending this to his young daughter, was not ready to have a baby, both physically and in terms of her life, in a general sort of perspective. So he went and confronted the manager of Target and said to him, "Why did you send this to my daughter?" Of course, he was just in charge of packing shelves. So he said, "Give me 2 weeks and I'll tell you what went on." He went back 2 weeks later And the target man was very apologetic. And he said, actually, I should be apologizing to you because there was a conversation that I didn't have with my daughter that she was actually pregnant, but she didn't know. But even though she didn't know, the AI that was looking at what she was browsing at in the shops and her shopping habit had rightfully detected the fact that she was pregnant before a pregnancy test. So the people writing this program, they're like, we didn't do anything unethically in their perspective when they're writing it. But clearly they had, and clearly it's had to stop. And I think because this is happening in a corporate setting, even getting ethics approval before doing the work doesn't exist, right? Because they're not trying to publish that. They're just writing predictive models. And now everyone monitoring us on the internet is selling our data and using it to manipulate our thinking and using it to control the behavior in the world. And it's very clear at that level that there's ethical issues. When I use AI and I start using it to produce medicines that can be used potentially to save lives or to make weapons, there are very clear ethical issues. But there's some other ethical questions that we've been looking at, I think they're very important too, which is if business or a government department are holding a large amount of information on you, then surely they have a responsibility to use that information to help the population, you, that's on the database, rather than to hurt you.
Wow, that's really a lot. I think that for upcoming leaders and scientists, this is certainly something to be thinking about. And on that point, I'm wondering what sort of advice you have for those interested in the field and would like to delve into it, because at least in the area of environmental science, David was recently discussing with me on how AI is being used to classify waste in the area of waste management, which of course makes a lot of sense to me because in AI is very helpful with classification. I mean, the basis of some of the things you mentioned, like SVM, random forest, it's really about classification of the data that we have. So for those interested in the field, what is your advice for them?
Well, work together, because if you ask me to classify rubbish, I would balk because I could produce a model, but it may be totally useless because I don't understand chemistry. I don't understand the environment. But at the same time, I could probably produce a much more reliable model than you can. And so I think it's really important to work together. In software engineering, which is another thing that I'm part of, we have this concept of agile. And the idea of agile is that you have to have a multifaceted team. The best way to develop something is to get a customer and actually ask them to spend 6 months as part of your team and learn about your mathematics, learn about your software, and you learn about their domain expertise. And by working together, you're going to get a good result. And we understand as software engineers that we need that customer, and without their actual involvement in the project. And here we're not talking about questionnaires, we're talking about them being educated about what we're trying to do and us being educated about what they need as friends. We pretty well should give up before you even try. So this is what's come out of the software engineering perspective. And another thing I think that's really good news is that when we've looked at software engineering of doing these jobs, initially people thought that they could succeed by having huge teams of 1,000 or 10,000 people. And by having a huge team, they break through. And because of the communication problems and the team management problems associated with huge teams, it actually works out that it's not an effective way of doing it. And so after one of these particularly bad projects, I think it was IBM, did a deconstructive review about it. And their final decision was that if they were asked to do a project like that again, they would choose the 10 best people and give them everything they asked for, leave them alone, and let them have a go. And after 6 months, if they'd made progress, they were going to succeed. And if they hadn't, the technology wasn't up to it. And if that didn't succeed, having a bigger group wouldn't make it succeed either. And I think this is a great opportunity for some of our smaller groups to really have a go, because even though you think, but there's IBM and there's Microsoft and there's really rich people there, unlimited resources to do this work, what can we do? And I would suggest it goes back to that adage that nothing really significant was ever achieved except through a really small group of people that sat around a table. And so having a small group of people working together have a great potential to succeed, because we can listen to each other and we can work together, and that will help us succeed in tackling these areas.
Fantastic. I love that response. So you've been working on AI problems for a long time now. I mean, machine learning problems. Where do you see the limits of this ML, AI, DL movement?
I think one of the things we have to be very careful about, and I think this gets into the ethics too, is that it is just mathematics, really. It's applicable mathematics, and that's what computer science comes into it. And AI tends to be particularly good at solving things within a small domain. If you look at what Elon Musk was saying about singularity and the potential damage of a breakthrough, intelligent AI, the AI would be optimizing some problem within its domain. So you might get an absolutely brilliant AI that's optimizing something like the reduction of CO2 in the world. And its conclusion might be the best way to do that is to wipe out humanity. And is that an optimal solution that we want to have?
Yeah.
I think that the thing about optimization is that in a high dimensional space, there can be a number of equally optimal solutions, but the AI doesn't have the bigger picture about what it's trying to do.
Yeah.
And so it may solve the problem by wiping out humanity. Yeah. It may solve the problem by finding an equally ludicrous solution, like forgetting about the environment at all.
Yeah.
And so the danger of a lot of these AIs is they're doing these optimizations that they're getting very good at, and their own self-preservation and obtaining greater resources to be able to improve their computation may be a far more likely outcome. And so they may in fact increase their economic wealth to build themselves a bigger computer so that they may be able to solve your CO2 problem and inadvertently burn up the atmosphere in the process. And so we have to have an external view of these systems because they're very focused. They're a little bit like me when I'm trying to solve a maths problem. I can get very involved in trying to solve this problem and forget to put pants on or something. It can be quite embarrassing. So we should avoid these embarrassing situations.
I believe you. This is a very good point that you made. Reminds me of the Avengers movie Age of Ultron. Ultron is just supposed to be a superhero created by Tony Stark and Iron Man, and who is supposed to end wars before they start. And his solution was to kill the Avengers because he found out that when the Avengers came up, more threats came in, and so it looks like the solution is to get rid of the Avengers, who will be his obstacle to dealing with the other problem, which is getting rid of humanity, killing all humans, and beginning everything all over again. I mean, Ultron was an AI. He's an AI technology, so.
Of course. Well, I think, Marvel, Disney are getting at that from a simplistic perspective. But I think probably the way these will really optimize is a slightly different way.
Yeah.
And so we have to be careful about what's going on, because a lot of these things are given a great deal of power in the modern world. Everybody talks about the influence of the YouTube algorithm and stuff like that.
Yeah.
Although I'm not sure if that's really an AI, but I think these things can end up really seeming malicious when it's really just an optimization as well.
Wow. Thank you so much, Peter. Folks, this has been awesome. Just getting warmed up, and yet we have to bring it to a close. But Peter, before we go, we allow you to greet someone or give out some shout outs to someone. Yeah.
Well, I suppose I'd shout out to all my friends, particularly my friends in Nanjing, and hope you're having a a lovely time today, but my brain's a bit sleepy at the moment to answer that question, right? Because I'm an introverted mathematician at heart. So,
all right. I've really enjoyed this, and I'll be doing a reflection session on this to reflect on some of the things that Peter said that may be a bit difficult to assimilate for some of our listeners, and just to break it down a little and to help everyone fully benefit from this. But it's been fantastic. Thank you so much, Peter. And we look forward to getting some feedbacks and pointing people in your direction. And Peter is always ready for some collaboration when you want to have conversations. So thank you so much, Peter.
thank you, Daniel. It's been great talking to you.
Thank you so much for listening to this episode of the Green Living Charts podcast. This has been the Research Stories segment. We believe that critical thinking is for everyone, and no one story is an island. We hope that you find where your story meets others here.
We look forward to hearing your thoughts and comments as we get interactive on our social media platforms at Echo Ahmed Solutions on Instagram, Facebook, YouTube, and LinkedIn. If you would like to be part of these conversations, contact us via email at glcpodcast@echoahmedsolutions.com or see our contact details in the show notes. See you on the next episode, and remember, live green.